Okay, hello everyone, and today we're gonna learn on how to represent molecular shape. Okay, how to represent a 3D molecules in a 2D space. Okay, so first, let's imagine we only have two pairs, two electron pairs, which means that it can be one bonding pairs and one lone pairs lah. Tapi in this case, since it is only two, kalau ada satu pun it will still be linear. Okay, since ada dua, the electron pair geometry, which is nama dia, is called linear. Okay, and then the number of bonding pairs in this case is 2 and lone pairs dia 0 lah, because kenapa I letak 2, because kalau satu pun, one bonding pairs and one lone pairs, the shape is still the same, because remember the shape we only look on the bonding pairs. Okay, contohlah kalau ini adalah one bonding pairs, one lone pairs, so contoh central atom, one bonding pairs with another atom and then lone pairs. Okay, it is a linear shape. Kita only tengok the bonding pairs. And kalau ada dua pun, contohlah, it is still linear. Sebab, remember VSEPR, they want to put themselves as far apart as possible to minimize repulsion. Okay. The class of molecule ni, dia ada banyak representation. But the most common representation is kita letak the central atom as A. Okay. Just jangan terkejut if they use different huruf lah. But we usually use A, and then dia punya keliling ni, not atom yang keliling central atom, we represent it as X. So in this case kita ada dua bonding pairs, so kita ada dua lah, dua pairs yang dia bonded to. Okay, so the molecular shape is, nama dia is linear, right? And cara nak lukis dia is very simple, linear. So just draw. Ini sebagai contoh je lah. Sebagai contoh A dengan X. Okay. And usually another thing yang diorang akan tanya is dia punya bond angle. So bond angle is 180 because it is a straight line lah. So it is 180. Example is carbon dioxide. While the carbon dioxide, dia punya molecule is shaped as C double bond O double bond O. Okay, like that. So it's linear, straight. Okay, let's go on to the next one. Okay, macam mana pula kalau kita ada tiga? Okay, tiga. So, untuk dia punya electron pair geometry, kita tak tengok dia punya number of bonding pairs or number of lone pairs. We only look on the how many total pairs yang ada. This include bonding and lone pairs. So kalau 3, the original electron pair geometry, the original shape dia is trigonal planar. So it is trigonal planar. Okay. Then, so kalau trigonal planar, usually kita akan ada 3 bonding pairs and tak ada langsung lone pairs. And the class of the molecule is sama juga, A as the central atom, X as dia punya atoms yang keliling dia, and kita ada 3, so 3 lah. And the name is trigonal planar. Trigonal planar. Just remember that question selalunya akan tanya is either electron pair geometry or molecular shape. Just remember, electron pair geometry is the total amount of electron pairs. Okay, the total. So, gerak pula. Apa ni? Kenapa dia gerak-gerak ni? Tak apa, saya tulis ni. Total. Where the class of the molecule after we took account of the lone pairs. Okay, apa yang lone pairs ni dah affect dia punya shape. Okay, so first kalau trigonal planar, so remember it is a triangle in a plane. So cara nak lukis dia is A, doesn't matter, so you like here, and you buat triangle lah. Buat triangle. And dia punya angle, okay, kalau if you remember, untuk a circle dibagi dengan 3, which is you akan dapat 120. So the angle is 120 degrees. Okay, and the example is aluminium bromide, which is an incomplete octet. Okay, so now let's look on apa jadi kalau kita still ada total pair of 3, okay, tapi now one of the pairs is a lone pair. Okay, now class of the molecule is based on electron pair geometry, cuma now it is distorted because one of the pairs are lone pairs. Okay, lone pairs tu gantikan bonding pairs tu. Okay, cara nak tulis class of molecule, kita still the same, A, X. Now kita ada 2 bonding pairs, and lone pairs kita can represent it as E lah. Okay, so the shape now, kita gantikan satu of the bonding pairs as dengan lone pairs. It is called V shape or bent molecule. Okay, and cara nak lukis dia is lukis the central atom. Okay, and lukis bentuk V, tak kisahlah untuk V ke ataupun V terbalik ke, is okay. And dia punya lone pairs yang you lukis is, you can lukis like that. So you lukis 2 dot and you buatkan orbital lah. Macam itu kita buat p orbital, kita buat macam teardrop punya shape. Okay. And the angle, if you remember, the lone pair to the bonding pair repulsion is way stronger than the bonding and bonding pair repulsion. Thus, dia punya angle here, okay, it will be less than 120 degrees. So you don't have to be exactly accurate untuk tanya soalan ni. Kalau soalan dia tanya angle, you just letak less than 120, it is acceptable. Okay, now let's look on kalau ada 4 lah pula. So kalau 4, the basic shape is called tetrahedral. So tetrahedral. Oh, saya tak cukup tempat. So it is tetrahedral. So it means it has 4 points. Okay, so let's see the very basic of tetrahedral punya shape, which is all of it are bonding pairs and none of it are lone pairs. Okay, what is the class of the molecule? Dia tanya class is you tulis the basic, the general formula for the molecules lah. So it is AX4, since there are 4 around the central atom. So the molecular shape is tetrahedral. So now what apa yang special now is, kalau you tengok, tetrahedral is not actually we can draw senang-senang because it's not actually in a plane lah. So macam mana kita nak draw? Okay, so cara nak draw, we use wedges, oh my god, and dashes. Okay, apa itu wedges and dashes? So let me give you an example. So I'm drawing a tetrahedral punya shape. So I draw a tetrahedral punya shape. I draw like this. Okay, and now the other 2 atoms yang keliling central atom, I draw it this way. X and X. Apa maksud ni? So wedges, wedges, okay, macam KFC wedges tu, it means that this molecule are outside of the plane. So maksudnya molekul ni are pointing at you, while dashes means that the molecules are pointing away from you. So let me give you a visual representation. So you tengok these 2 molecules are in a plane lah. Okay, and I think yang we draw just as a bond is in a plane. Okay, so this is in a plane. Okay, so bayangkan this is in a plane where this X is belakang, is depan, and this is belakang plane tu. Okay, boleh bayangkan? So where this X is keluar kat depan, while this X is keluar kat belakang. So this is a tetrahedral shape. Right? And the bond angle is 109.5 degrees. So 109.5, just remember, okay, 109.5. So another example is, what if one of the bonding pairs sekarang become a lone pairs? Okay, so cara nak tulis the class of molecule is A, X, kita ada 3 bonding, so 3 and 1 lone pairs. Now the shape, okay, kita ganti any of this, tak kisah mana satu. So bila kita ganti dia as a lone pair, okay, remember the shape is only, kita only tengok the bonding pairs. So ia akan jadi, the name is trigonal pyramid. Okay, so because it is a pyramid that has three, is in the shape of a triangle. Okay, so cara nak lukis dia is A. So I'm showing you the simplest way untuk lukis lah. X, 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 and the lone pair you letak dekat atas. Senang. Okay, so this is a trigonal pyramidal. Some books call it trigonal pyramid, some books call it trigonal pyramidal. Both are correct. Okay, so the angle between the bond, because the angle yang kita tengok is only between the bond, is obviously less than 109.5, because lone pair to bonding pair repulsion is stronger than bonding to bonding pair. So this is dia punya angle 0.5. Okay, another example is, kalau instead of just one, kita letak dua bonding pairs. Okay, so we have 2 bonding pairs and 2 lone pairs. Okay, what is the shape? Kalau you tengok, kita ganti any of this, dia akan jadi bentuk V shape balik. So it is V shape ataupun bent molecule. Okay, molekul yang bengkok lah, bent shape. Okay, cara nak lukis dia is, the easiest way is you also follow this lah. So one of the way yang I lukis is like this. Still follow. And then, okay, this is not, you tukarkan this menjadi dia punya bonding lone pairs. So X, you letakkan lone pair dia dalam the same plane. Okay, one example, a very abundant example of this kind of molecular shape is water. Okay, water, kalau dia punya shape, dia punya angle is 104.5. It is very specific. Okay, but kalau lah ada molekul yang also have 4 total pairs, and which is 2 bonding pairs and 2 lone pairs, cara awak nak tulis dia punya angle is this angle, because sekarang instead of 1, kita 2 lone pairs. This one is very strong, repulsing each other. It's very simple. You just buat small and smaller than 109.5. So the angle is, you just put the small punya bracket tu twice, 109.5. Okay, so now let's look on kalau kita ada 5 pairs. So 5 pairs, dia punya electron pair geometry, the nama dia is trigonal bipyramidal. Trigonal bipyramidal, which is, maksudnya ada 2 piramid 3 segi yang tangkup each other lah. So ada 2 piramid 3 segi. So let's see in the basic punya shape, which is tak ada langsung lone pairs. The class of the molecule is AX5. Molecule shape is still the same, trigonal pyramidal. The nama and the shape only change if kita ada lone pairs. Kalau tak ada lone pairs, it is the basic shape. Dia ada 5 basic shape tu. trigonal bipyramidal. And cara nak lukis dia is kita always start dengan central atom. So kita start dengan central atom. This is example of central atom. Put the other atoms yang are in plane. So in plane, dalam plane, and we have dua atoms yang terkangkang. So we put wedges, maksudnya dia are pointing towards us, and another one is pointing away from us. That is the shape. Untuk trigonal bipyramidal is a bit special because dia ada dua angles. Kalau you guys tengok, we actually have two types of atoms keliling dia. We have axial and equatorial lah. So untuk this, you guys tengok, this angle is 90 degree, while this angle is the same as trigonal pyramidal, which is 120 degrees. So cara nak tulis bond angle dia, just tulis dua-dua lah. We have two bond angles. So we have 90 degrees and 120 degrees. Okay. So now let's look on kalau kita one of those bonding pairs, kita tukarkan jadi lone pairs. So dia punya class of molecule AX4E, and the shape is called seesaw. Seesaw. Kenapa seesaw? Because kalau you guys tengok, the one yang kita nak buang is kita buang dekat pinggang dia. Okay? Kita buang dekat pinggang. The reason why kita buang dekat pinggang is sebab you can minimize the most repulsion. Sebab you tengok, kalau you buang dekat sini, dia ada 90 degrees, 90 degrees, 90 degrees. Untuk here, okay, kalau you buang kat pinggang, you boleh minimize 90 degrees and also 120 degrees and 120 degrees punya repulsion, and also dekat bawah ni kan, ada also 90 degrees dekat bawah ni. So we can minimize more repulsion. So kita kurangkan repulsion dalam this molecule. So cara nak lukis is very simple. So lukis. So my tips is kalau boleh letak the lone pairs in plane, but in this molecule we have no choice lah kan. So letaklah dekat sini. So I buang dekat sini. And then other molecules, other atoms keep the same. Jangan ubah. So this is a bit tricky because there's something that different. Okay. Now kalau you guys tengok apa yang dia tolak. Okay. Dia tolak. Okay, this angle is still the same. Okay. This angle is still the same, right? But now apa yang dia tolak is dia punya dekat pinggang tu. Dia tolak yang atom-atom yang dekat pinggang. So now dia punya angle yang atas ni, yang straight tu, yang axis tu is still the same. But now yang dekat pinggang tu dia dah berkurang menjadi less than 120 degrees. Okay. Let's look on the next examples, which is now we have 3 and 2 lone pairs, and dia punya class is AX3E2, and the shape is called T shape. Okay, T shape. Kenapa dia bentuk T shape? Okay, T shape because if you look here, okay, it's easier kalau you nak letak this lone pair dekat sini, so it's easier for you to see. I letak the lone pair dekat yang dashes dengan wedges. So let's see macam mana kita nak draw. So A, lone pairs. So this one also lone pairs. So look at here now. Okay, remember the shape, we only look at the bonding pair. So kalau you tengok the bonding pair, dia bentuk macam T. So this is called a T shape. It's a T shape. So it's good untuk lukis around the lone pairs because lone pairs are delocalized electrons. So electrons yang tak ada siapa nak ambil. So dia orang sebenarnya dia orang are not actually duduk dekat dua macam ni. diorang actually boleh duduk dekat mana-mana yang bentuk macam ni lah. So we generalize it as a orbital punya shape. Okay, so angle dia, sekarang kita only left with one angle actually. Sebab kalau you guys tengok, okay, kita only, remember we only look at the angle of the bonding pairs. Okay, apa-apa yang semua kita tengok bonding pairs saja, kita bayangkan lone pair tu tak wujud. So actually we only have one angle. We only have here. Tapi now, okay, we have two very big lone pairs. So these lone pairs are pushing this bond closer to each other, becoming less than 90 degrees in angle. So less than 90 degrees in angle. That's it. So now, tengok kalau what if we have more bonding pairs, then we have more lone pairs than we have bonding pairs. Okay, AX2E3. Now it will become linear. Okay, kenapa? Because remember, untuk trigonal bipyramidal, we are removing dia punya atoms-atom dekat pinggang dia. Okay, pinggang dia nak lose dia punya weight, so dia buang lemak-lemak dekat pinggang dia. Okay, so kita buang dekat sini, so the shape become telah menjadi linear. Salah. And here. So dia ada lone pair keliling pinggang. So the shape. So now keliling pinggang dia are equally have lone pairs. So they are pushing, okay, they are pushing the bonding pairs equally atas and bawah. So the bond angle now dah jadi exactly like linear 180 degree tepat. Okay. So now let's go on to the final one. Kalau kita ada 6. So 6 kita have, it is the basic shape is called octahedral. Octahedral. And the basic shape ada semua bonding and tak ada lone pairs. The class of molecule is AX6. The name sama. Okay. So octahedral. Octahedral. And cara nak lukis dia, you have to be quite lukis cantik lah. Sebab kalau like exam nanti it's quite messy kalau you tak guna pembaris. So lukis the central atom dulu. Lukis atom yang dalam plane. Okay. And kita lukis dua. Actually, if you remember, sama je macam lukis axis yang saya ajar masa nak draw the orbitals tu. So we have straight, we have X dekat tengah dia. So we have satu keluar kat belakang and satu keluar kat depan, X. And also we have another one is satu yang dekat belakang, satu dekat depan. Alright, this is the shape. Okay, kalau you tengok, every single atom are equally spaced apart. So dia punya angle is 90 degree. So anywhere you look is 90 degree. Sini pun 90 degree. Sini dengan sini pun 90 degree. So it's only 90 degrees. Okay, now if one of the atoms are replaced with the lone pairs. So 5, 1, A. So AX5E. So it is now called square pyramidal. Square pyramidal. Kenapa it is square pyramidal? It is in the name. It is a pyramid that is have a square base. Okay. So cara nak lukis dia, you can choose nak letak atas atau bawah. Saya suka letak bawah dia punya lone pairs. Right. And the square pyramidal is shaped like this. Right. So that's the wedges. So it is X, 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 and X. So this is a shape of a square pyramid. So I draw this cantik sikit. Hayya. So it is a pyramid that is square. So now the angle is this lone pairs are pushing every single thing close. Salah color. Are pushing everything stronger than the bonding pairs. So dia macam nak tolak, macam ibarat nak tutup payung. Dia nak tutupkan payung ni. So the angle now are less than 90 degrees. Okay. So let's see kalau kita 4 and 2 pula combination. So we have 4 and 2, which is AX4 E2. Apa shape dia? Mana nak letak? So untuk minimize repulsion, okay, kalau kita letak sebelah dia is very strong kan, bonding lone pair to lone pair is very strong, dia punya repulsion. So kita letaklah atas. So dia punya shape now become square planar. Kenapa dia square planar? Because now here is A, atas and bawah dia kita dah letak lone pairs. Okay, these lone pairs are pushing the atoms keliling dia equally. So now dia macam dah terpenyet. Atas tolak, bawah tolak, dia terpenyet. So the bond angle jadi exactly 90 degrees balik. Okay, one way of remembering this, I know banyak, is do the exercise, do the tutorial, and also lukis cantik-cantik and try to memorize it lah. Tak banyak pun. We have 5 basic shape and a few reiteration of the shape lah. Okay, now is we actually have more. We have more shapes, but in the syllabus we only cover this much lah, tak banyak sangat pun. So how about 2 and 3? Now what if kalau sama, kita ada 3 bonding, 3 lone pairs. So the class of molecule is AX3E3 and the molecule shape is T-shape. Kenapa T-shape? Sebab tadi kita letak atas and bawah, right? Atas and bawah kita letak. Another possible way is kita letak is in each of these 4 lah kan. So kita letaklah dekat mana-mana saja pun. So cara nak letak, so cara yang easier untuk you visualize, it is a T-shape. So saya letakkan the lone pairs dekat dia punya yang wedges dengan dashes. Okay. So this is where I put my lone pairs. Okay. And here is my bonding pairs. Okay. Nampak tak? This make a T-shape. This make a T-shape. Now the bond angle, since kita ada the lone pair and it is no longer equally tolak atas bawah, kita have another one. So the lone pairs, the bonding pairs now sekarang dia punya bond is 90 degree awal-awal. Now it is less. So it is less than 90 degree. Sebab kita ada banyak lone pair yang tolak them each equally. Not equally lah, sebab kita ada another one yang tambah to the repulsion. So now on the final one, which is 2 and 4. Okay. X2 and E4. Now the shape is called linear. Kenapa dia jadi balik linear? Okay, kalau if you perasan banyak-banyak, kalau the more kita tambah, at the end usually akan jadi linear balik. Okay. Now kita tambah another way nak letak, kalau sini the repulsion is quite strong lah. Kita letaklah dekat sini because this one dah ditolak. Okay, dia dah ditolak oleh the lone pairs or lone pairs. Why don't we just change it into a lone pairs lah? So this shape. So how I draw this, I usually akan draw the one in dashes dengan wedges dulu. So it's easier. Alright, dah macam butterfly and we have the bonding pairs straight through macam ibarat Z axis. So now kita have all equivalent lone pairs ni ditolak equivalently untuk these two bonding pairs. So now dia punya bond angle dah jadi exactly 180 balik. Okay. So that's it for the gap handout.